5 seconds. That's all you need to survive. Just 5 seconds on the surface of Venus, the hottest planet in our solar system. Clouds of sulfuric acid float above you. The atmospheric pressure is 90 times stronger than Earth's, enough to crush a submarine. The temperature is hot enough to melt lead. Your suit is all that stands between you and instant death. Can you survive just 5 seconds on this hellish world? Let's find out. Welcome to hell. Yep, sorry. I meant Venus. Welcome to Venus. Some people call it Earth's twin because of its similar size. But this world is nothing like home. In fact, Venus is the most hostile planet in our solar system. More hostile than Mercury, which faces the sun directly. More hostile than the frozen outer planets. Venus is a toxic, scorching, crushing nightmare. And you're about to experience this hellish landscape firsthand. Your mission is simple. Spend just 5 seconds on the surface of Venus. Touch down. Complete your objective. And get back to your spacecraft before this planet kills you. Trust me, these are going to be a very long 5 seconds. Every moment will feel like an eternity as Venus tries to destroy you in multiple different ways, simultaneously. The heat, the pressure, the toxic atmosphere, they'll all be working together to end your life. Let's begin your journey to the closest thing to hell that exists in our solar system. Venus is our nearest planetary neighbor. At its closest approach to Earth, Venus is a mere 40 million kilometers away from us. That might sound like a vast distance, but in cosmic terms, it's practically next door. Venus is closer to us than any other planet. After about 4 months of space travel from Earth, you'd finally be able to witness this beautiful but deadly planet up close. And from a distance, Venus truly is beautiful. It's one of the brightest objects in our sky, so bright it can cast shadows on Earth at night. Ancient civilizations worshipped it. Poets wrote about it. But that beauty is deceptive. Venus is covered in thick clouds that reflect sunlight brilliantly, making the planet shine like a pearl in space. Those clouds look serene and lovely from afar. Up close, they're anything but. As you approach Venus in your spacecraft, you'd see the planet growing larger in your viewport. The dense cloud layers would swirl and move. Lightning would occasionally flash through the clouds. Venus has more lightning than Earth. The storms here are violent and constant. You'd prepare yourself mentally for what's coming. You've studied the data. You know what happened to the robotic probes we've sent to Venus. Most lasted only minutes. You're hoping your advanced suit technology will let you survive just 5 seconds longer than any machine has. 4.5 billion years ago, Venus and Earth formed in the same corner of our solar system from the same cloud of dust and gas orbiting the young sun. They're siblings in a sense, born from the same material at roughly the same time. This space rock is about the same size as Earth, just slightly smaller, with a diameter of about 12,100 kilometers compared to Earth's 12,700 kilometers. The difference is negligible. If you could see Venus and Earth side by side, they'd look like twins. Venus's gravity is also similar to Earth's, about 90% of Earth's surface gravity. If you could stand on Venus, you'd feel almost as heavy as you do on Earth. Your muscles would work almost the same way. But that's where the similarities end. Unlike our home, the surface conditions on Venus are absolutely extreme. While Earth developed into a life-supporting paradise with liquid water, breathable atmosphere, and moderate temperatures, Venus became a toxic hell world. We know this because we've sent probes to this scorching world over the decades. Some probes orbited Venus, taking measurements from a safe distance. Some made flybys, passing close to gather data before continuing on their way, and some brave robotic missions actually landed on the surface of Venus. But those surface landers didn't last very long. Some survived mere minutes. The longest survival time was just over 2 hours. Then the extreme environment destroyed them. What happened to these probes? Well, that's what you're about to experience firsthand. Time to make your descent to the surface. You seal your helmet, check your suit integrity one final time, and begin your descent through Venus's atmosphere. At first you'd encounter the beautiful cloud layers. Don't these clouds look stunning? Yellowish bands streak across the sky in mesmerizing patterns, swirling and flowing in the fierce winds. From inside your protected spacecraft, they're breathtaking. But don't be fooled. Don't inhale them if your helmet were to crack. These yellowish bands streaking across the sky are clouds of concentrated sulfuric acid, the same chemical used in car batteries but in vapor form, drifting through the atmosphere in massive cloud banks. If you could somehow get a whiff of these clouds, which you absolutely should not try, you'd smell the reek of rotten eggs. The hydrogen sulfide and sulfur dioxide in the atmosphere create that distinctive stench. But to smell anything, you'd need to remove your helmet, and I definitely, absolutely do not recommend that. You'd be dead within seconds. At a height of 50 kilometers above the surface, visibility becomes very poor. You'd hardly be able to see anything through the thick haze. The incredibly thick atmosphere would block your views of the planet below and its tens of thousands of volcanoes. The atmosphere here is mostly made up of carbon dioxide, about 96%. The remaining 4% is nitrogen and trace gases. And because the atmosphere is so incredibly thick, 93 times denser than Earth's atmosphere, it traps heat on the planet's surface in an extreme greenhouse effect, keeping Venus nice and toasty. Just how toasty are we talking? Oh, you're going to find out the hard way very soon. As you descend another 15 kilometers deeper into Venus's atmosphere, the haze would finally begin to clear. The world below would start to reveal itself through the thinning clouds. You'd see a rust-colored surface covered in mountains and volcanic formations stretching to the horizon. The landscape is alien and beautiful in its own hellish way. Rolling plains of ancient lava flows, towering volcanic peaks, impact craters from ancient asteroid strikes. Look, one of those volcanoes appears to still be active. You can see fresh lava flows on its slopes, glowing faintly in the dim light. Venus has more volcanoes than any other planet in our solar system. Over 1,600 major volcanoes and possibly tens of thousands of smaller ones. You'd maneuver your spacecraft carefully, flying around to collect atmospheric samples and take detailed images. The scientific data you're gathering is invaluable. Your instruments confirm what we already knew. The atmosphere is mostly carbon dioxide with traces of nitrogen and sulfur compounds. The readings check out with previous probe data. The air outside is thick and soupy, more like a fluid than a gas. Your spacecraft pushes through it slowly, fighting against the dense atmosphere with every movement. Okay, let's see if you can land safely. You spot what looks like a relatively flat area. A good landing site. You check your systems one more time. Everything shows green. Well, as green as things can be when you're about to land on the most hostile planet in the solar system. There's no signal from Earth anymore. The thick atmosphere blocks radio communications. You're completely on your own now. You initiate the landing sequence without clearance from mission control. Fingers crossed. Your spacecraft descends the final few hundred meters. The landing thrusters fire, slowing your descent. You brace for impact. The spacecraft touches down. Landing your craft on Venus's surface kicks up massive clouds of dust and fine particles that would take several minutes to settle down in the soupy, thick atmosphere. The dust moves slowly, almost floating in the dense air rather than settling quickly like it would on Earth. As the dust gradually clears, you look up through your viewport into the sky, but you wouldn't find the familiar yellow circle of the sun up there. On Venus, it always looks like dawn or dusk, no matter what time of day it is. The sky has an eerie orange glow, dim and murky. That's because the thick Venusian atmosphere only lets about 10% of the sunlight that hits it actually reach the surface. The rest is reflected back into space or absorbed by the cloud layers. Even at noon on Venus, it would look like twilight on Earth. Wait, what were we saying earlier about the space probes that landed on Venus? Oh yeah, let's talk about Venera 13. You should know what happened to the most successful lander before you step outside. This Soviet probe made its fatal landing back in 1981. It was designed to survive Venus's extreme conditions for as long as possible, with heavy insulation, reinforced pressure vessels, and cooling systems. Venera 13 survived the descent through the toxic atmosphere and landed successfully. Then it operated on the surface for a whopping 127 minutes, 2 hours and 7 minutes. That's longer than any other spacecraft that had ever made it to Venus's surface, before or since. For those precious minutes, Venera 13 sent back the first color images from Venus's surface. It analyzed soil samples. It recorded atmospheric data. It gave humanity our first real look at the hellish conditions on Venus. But then Venera 13 gave way to the violent, uninviting environment of this world. The extreme heat and pressure eventually overwhelmed its protection systems. Scientists believe it was likely crushed under the extreme atmospheric pressure or melted by the incredible heat, or both. The probe went silent, another casualty of Venus. That was over 40 years ago with 1980s technology. Your suit is far more advanced. But still, the fact that even a heavily reinforced probe only lasted about 2 hours should give you pause. And you're planning to spend just 5 seconds out there. Should be fine, right? It's too late to turn around now. You've lived through the descent and the 1-hour landing procedure. You're on the surface of Venus. You're so close to completing your mission. All you need to do is spend 5 seconds outside. Just 5 seconds out there in the most extreme environment human beings have ever attempted to survive. You check your suit one final time. Pressure seals, good. Thermal protection, good. Oxygen supply, good. Emergency return protocols, ready. Everything is as prepared as it can possibly be. You open the airlock. The moment the external hatch opens, you feel the oppressive atmosphere pressing against your suit. You take your first step onto Venus's surface. Whoa. The atmosphere is so dense and strange that you can hardly lift your arms. Even though Venus has about the same gravity as Earth, 90%, which should feel almost normal, you'd be feeling the sheer weight of its immensely dense air pressing on you from all directions. It would feel less like walking on a planet and more like walking through very hot water. Every movement requires effort. The thick atmosphere resists your motion. It's like being deep underwater, except the water is superheated carbon dioxide at extreme pressure. You'd be extremely glad you were wearing so much protective gear right now. A quick glance at your suit's external thermometer would tell you that it's a sweltering 475 degrees Celsius out here. That's about 900 degrees Fahrenheit. That's hot enough to melt lead, zinc, and tin. Hot enough to make aluminum glow red. This isn't the hottest temperature because Venus is closest to the Sun. Mercury actually gets hotter during its day because it's closer. But Mercury's temperature varies wildly between day and night. Venus maintains this hellish temperature constantly, day and night, everywhere on the planet, because of the extreme greenhouse effect from its thick carbon dioxide atmosphere. Your pressurized suit would be working incredibly hard to keep you safe from the crushing pressure. The atmospheric pressure on Venus is 92 times that of Earth at sea level. That's equivalent to being 1 kilometer underwater in Earth's oceans. Without your suit, you'd be crushed under all that pressure before you could even take 2 steps. Your ribcage would collapse. Your internal organs would be compressed. The pressure would squeeze the air out of your lungs and prevent you from inhaling. But your suit is holding. The advanced materials and active pressure compensation systems are doing their job. You're actually surviving on Venus's surface. This isn't so bad after all, you think. If a spacecraft could last over 2 hours, some 40 years ago, with primitive technology, surely you and your shiny new advanced suit can survive longer, right? Venus is right here for you to discover and document. Just take a few more steps, collect your samples, complete the mission. You reach down to pick up a rock sample from Venus's surface. Suddenly something goes catastrophically wrong. A seal fails. A joint gives way under the pressure. Your protective suit breaks. The drastic pressure shift would immediately make you feel like you'd been thrown into the deep ocean. The atmospheric pressure, 90 times that of Earth, would begin crushing you from all directions simultaneously. Venus would be compressing your body with the force of 90 Earths pressing down on you at once. Your suit's integrity breach means the external pressure is now directly affecting your body. You can feel your chest being squeezed, making it nearly impossible to expand your lungs. You'd be struggling desperately to breathe in an atmosphere without any oxygen whatsoever. The air on Venus is 96% carbon dioxide. There's no oxygen to breathe. Even if you could somehow inhale against the pressure, you'd be suffocating. But it gets worse. Any of that 475-degree atmosphere that you did manage to inhale would instantly scald the inside of your mouth and the top of your throat. The superheated gas would burn your airways as it entered your body. The heat would be cooking you from the outside too. Your skin would begin to blister and char. Your eyes would dry out and be damaged. The heat would be unbearable, overwhelming your pain receptors. You have maybe 5 seconds, maybe, to scramble back into your spacecraft and seal the airlock. 5 seconds to save your life. That's why this was your mission time frame all along. Not because you were supposed to casually spend 5 seconds exploring Venus. Because 5 seconds is all you'd have if something went wrong. Unless you can get back to the safety and pressurization of your spacecraft within those 5 seconds, you'd be dead, crushed, suffocated, and cooked all at the same time. Not a pleasant way to go. Actually, you know what? It could be worse. At least you don't have to deal with one of Venus's other hazards. High above you in those beautiful yellowish cloud layers, sulfuric acid rain is constantly falling. Drops of concentrated acid precipitate out of the clouds and begin falling toward the surface in a toxic rain shower. But here's the thing. In this unbearably hot environment, that toxic rain never actually reaches the surface. The temperature is so high that the sulfuric acid rain completely evaporates long before it gets down to ground level. It falls, evaporates back into vapor, rises back up, condenses into clouds again, and repeats the cycle endlessly. So at least you wouldn't have to worry about acid rain dissolving your skin and bones while you're dying from heat and pressure. That would be kind of gruesome and would just add insult to injury. Small mercies, right? The acid is still up there, still falling, still a threat if you were at altitude. But down here on the surface, it's just one less thing trying to kill you among the many, many other things that are absolutely trying to kill you. In hindsight, maybe we shouldn't have sent you down to explore this hellish surface at all. This was probably a terrible idea from the start. We probably should have terraformed Venus into a more hospitable planet first, before attempting any human surface missions. Change the atmosphere, cool it down, reduce the pressure, neutralize the acid clouds, basically remake the entire planet. Then maybe, just maybe, humans could survive there. But terraforming Venus would take centuries or millennia with our current technology, and we were impatient. We wanted to set foot on our sister planet now, not in 1,000 years. So we sent you on this 5-second suicide mission to Venus. And honestly, we're not sure if you're going to make it back to your spacecraft in time before the pressure, heat, and toxic atmosphere kill you. If you do somehow survive and make it back to tell the tale, you'll have earned the distinction of being the first human to touch the surface of another planet and live to talk about it. That's something at least. And if you don't survive, well, at least you'll have company. Venera 13 is still down there somewhere, crushed and melted, a monument to human ambition and the absolute brutal hostility of Venus. 5 seconds on Venus. That was the mission. The longest 5 seconds of your life, assuming they weren't the last 5 seconds of your life. If you enjoyed this journey to the most hostile planet in our solar system, subscribe for more explorations of extreme environments and the limits of human survival. Stay curious and maybe stay away from Venus.